بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضات لغات، السلام عليكم ورحمة الله وبركاته. اليوم سنتناول درس في مادة الاستاتيكا وهو مسائل على العزوم. Welcome my dear student in our math program for secondary 3. Today we are taking problems about moment. What is the moment? My dear student, from the previous we know that the problem about moment may be the moment of the force equal product of R times F or R cross F. What is R? R is the position vector of the point of the moment which act on it. What is the force? The force is magnitude or the direction force of the moment. My dear student, look at the first example. Problems about moments. First example. If the force F equals 4I minus 3J act at point A, 2, 3. Find the moment vector of the force F about the origin point A, number 2, the point B, which be its coordinate -1, 2. My dear student, we have force F equals 4I minus 3J, point A, 2, 3. The required moment about the origin point. Look at the solution. The first, my dear student, find the position vector of point A, OA, equals A minus O, equals this point A, 2I minus 3J. Moment about O equals OA cross F. What is the coordinate of point A, 2I plus 3J cross 4I minus 3J? 2 times -3 minus 3 times 4. Then answer is -18K. This is the vector of moment about origin point. My dear student, this force F, this point A, F act on A, 2, 3, this origin point O. This R1 position vector of A. Number 2, find the moment about B. Then BA vector equal A minus B, 2I plus 3J minus -I plus 2J equal 3I plus J. This is the position vector of BA. Moment about B equals BA cross F. What is the BA? 3I plus J cross, what is the F? 4I minus 3J, then by 3 multiply 3 times -3. This is the vector. 3 times -3 equals -9 minus 1 times 4 equals what? -12K. This is the moment about B. Look at this force, this point A, 2/3, this point B, -1, 2. This, what is the moment about the force F about point B? As a first, we find the value of BA by subtract A minus B. After that, the position vector of B cross F to find the moment of the force F about point B. Another example. If the force F, 3I minus 4J, act at the point A, 2, -1. Find the length of perpendicular drawing from the point B, 8, -4, on the line of the action of this force. My dear student, look at the solution. First, find position vector BA, A minus B. A minus B equals negative 6I plus 3J. The moment about B, my dear student, BA cross F. Then BA negative 6I plus 3J cross F, 3I negative 4J. Multiply negative 6 times negative 4, 24, minus 3 times 3. Then, my dear student, the moment about B equals 15K unit. My dear student, this is the moment. What is the length of perpendicular? The length of perpendicular equal norm of moment of the norm of F. Moment equals 15, moment F equals square root 3 power 2 plus negative 4 power 2 equals 5. Then the length of perpendicular equals what? Norm B over F. 15 over 5 equals 3 length unit. Another example. If the force F1 equals I minus J, also F2 for I plus J, F3 equals 2I plus 2J. We have three forces. At the point A, negative 4, 1, B, negative 1, 2, also C, 2, 0. D, negative 4, negative 2. Proves that moment that the line of action of resultant number 1 parallel BC, number 2 bisect CD. My dear student, when we prove that the moment parallel to side BC, we must prove that moment about B equals moment about C. If moment about B equals moment about C, then the moment parallel to BC. If the moment about B equals negative moment about C, then this bisect BC. My dear student, don't forget, what is the moment? The moment equal position vector cross F. My dear student, also don't forget length of perpendicular equals what? X student. Norm of the moment over norm of F. My dear student, look at solution of this example. Solution. Look at, my dear student, number 1, R vector equals F1 plus F2 plus F3 is the resultant of the forces which act at the point. By adding I with I, J with J equals 3I minus 2J in two direction. BA, position vector of B equals A minus B, negative 4I plus J minus negative 1I plus 2J equal negative 3I plus J. Moment about B, moment of resultant about B equals BA times R, vector. Then BA equal negative 3I minus J cross 3I minus 2J. By using negative 3 times negative 2 minus 1 times 3. Answer is 9K. My dear student, CA cross R is moment about C. By using the same method, negative 6I plus J cross 3I minus 2J equal 12 plus 3K equals also 12 minus 3K equal 9. Since moment about B equal moment about C. The line of action F parallel to BC. My dear student, moment about C equals 9K. Also, we are find moment about D. The first, find dA position vector of point D equals A minus D. Negative 4I plus J minus 4, negative 4I minus 2J equals 3J. Then moment about D equals moment of F about D, dA cross F or cross R. R is a resultant, equals 3J times 3I minus 2J equals negative 9K. Then what do you deduce, my dear student? Moment D equals negative moment C. Then we deduce that, my dear student, moment C equals negative moment D, the line of the action of F bisect of CD. My dear student, look at another example. Find the algebraic measure of moment of the force whose magnitude F equals 15 Newton about the point A. Solution. Look at, my dear student, look at this figure. We have AB and the force. What is the length? AD. Then what is the force? 15. Angle between BC and CA equals 150. Then measure angle ACD equals 30. We know that the line which opposite angle 30 equal half length of hypotenuse. Then L equals half what? Half AB. L, my dear student, this isosceles triangle 4, its side length CA equal CB equal 4 centimeter. AD perpendicular to BC, then length of arm equals AD. AC sine angle AB ACD equal 4 times sine 30 half equals 2 centimeter. Then moment about A equal F times L equals 15 times 2 equals 30 Newton centimeter. Look at, my dear student, moment about A equal norm F times norm AC sine theta. This rule, 15 times 4 sine 150 also equal 30 Newton centimeter. Moment of the force F equal 15 Newton about the point A. Draw AD perpendicular to BC, then the length L equals, by using Pythagoras theorem, 3 centimeter. Then moment about A equal negative F times L equals negative 15 times 3 equals negative 45 Newton centimeter. Another example. A, B, C, D, H are 5 points on a straight line such that AB equal 4, BC equals 6, CD equals 2, DH equals 3. The parallel force is 30, 25, 40 newtons act at A, C, H respectively in same direction perpendicular to AH. The two forces 50, 20 Newton act at BD perpendicular to AH and opposite direction to the three other forces. What is required? Find the algebraic sum of moments of these forces about each of A, C, and H. Solution. Look at, my dear student, we have 5 points belongs to AB. A, B, C, D, H. We have 2 forces at A and 3 forces at A and C and H in same direction downward. 40 at A, 25 at C, H at 40, Also, we have two forces act upward or vertically at B50, at D20. Moment about A equals 30 times distance 0, 25 times 10, 40 times 15, negative 50 times 4, negative 20 times 12 equals 420 Newton. Moment about C by the same method, my dear student, negative 30 times 10 plus 50 times 6 plus 50 times 0, negative 20 times 2 plus 40 times 5 equal 160 Newton. Remember, my dear student, moment about point equals the force multiply the distance or perpendicular distance from the point to the force. Moment about H equals negative 30 times 15 plus 50 times 11, negative 25 times 5 plus 20 times 3 plus 40 times 0 equals 35 Newton centimeter. Another example. ABC right angle triangle at B, where AB equals 6, measure C equals 30 degrees. The force F act in the plane of a triangle if the moment of F about B is equal 42 root 21 Newton centimeter, and the moment of F about C is 42 root 21 Newton centimeter, and its moment about F vanishes. Yeah, what you mean vanishes? Equals 0. The required, then find F and the direction of its line of action. Solution. Moment about A equals 0, then line of the action of the F passing through A, this number 1. Moment B equals negative moment C, the line of action of F bisect BC. Therefore, line of action of F passing through point D. The line of action of F is positive. My dear student, from 1 to 3, AD is the line of action of the force F. BC equals 6 root 3 centimeter. Also BD 3 root 3. AD equals square root by using Pythagoras 3 root 7 centimeter. Then BN equals 6 times 3 root 3 over 3 root 7 equals 6 over 7 root 21. The moment about B, F times 6 over 7 root 21 equals 42 root 21. Then F equals 49. Another example. ABCD is a rectangle in which AB 5 centimeter, BC 12 centimeter. The forces of magnitude 8, 15, 17, 10, 27 Newton act along BA, BC, CD, DA, and CA respectively. We have 5 forces, my dear student. 8 act in BA, 15 acts at BC, 17 acts CD, 10 acts DA, 26 at CA respectively. Find a point H belongs to AB such that the algebraic moment of H equals 317 Newton centimeter in ABCD direction. Number 2, find a point O belongs to BC such that the algebraic sum of moments about O equals 116 Newton centimeter in direction DCBA. Look, AC equals square root 25 plus 144 13 centimeter. Solution. My dear student, look at ABCD is a rectangle. AB act at 8, 8 at AB, 15 BC, 17 CD, 10 DA. Also, we have 26. Look at, my dear student, we have point N and point M belongs to AC. Point H belongs to AB. Point O belongs to BC. Sum of moment about H equals negative 317. Let AH equal X centimeter. Draw HM perpendicular to AC. HM equals AH sine BAC by using AHX sine BAC opposite over hypotenuse BC over AC. Then 12 over 13x, this is HM. Negative 15 times 5 minus x, moment. Negative 17 times 12, negative 10 times x, negative 24. X times negative 2 times 12 over 13x equal negative, the moment negative 317. Find the value of x by using division. X equals to 38 over 19, then x equal 2 centimeter. What is H? AH equals 2 centimeter, then H at 2 centimeter from A. Also, let CO equals y centimeter, BO equals 12 minus y. Sum of moment about O is moment O equals 116 Newton centimeter from the given. Then, my dear student, 8 times 12 minus y, side bracket, negative 17y, negative 10 times 5, negative 26 times 5 over 13y equals 116. Then, by using the solve this equation to find the value of y equals negative 2. What do you mean? O lies on BC, ray doesn't belong to BC line segment, such that CO equals 2 centimeter. Another example. The force F, my dear student, 8I plus 6J act at A, 1, negative 1, using moment, proves that the line of action F passing through the point B, negative 3, 2. My dear student, how to prove that the line of action F passing through B, negative 3, 2 means moment at B equals 0? Solution. R vector BA vector equals A minus B equals 4, negative 3. For I, negative 3J. Then the moment, my dear student, about B, R vector cross F vector, 4, negative 3 times 8, negative 6. What is the 4 times negative 6, negative 24, minus negative 3 times 8, positive 24 equals 0. Then moment about B equals 0. Therefore, we deduce that the line of action of F passing through this point. Another example. If A6 negative 9, B1 3, C4 negative 1, and we have force F1 of magnitude 39 Newton act at AB direction, and the force F2 of magnitude 35 Newton act BC direction. If Ij are two units vector in direction OX and OY respectively, and the unit distance is measured in centimeter, what is the required? My dear student, first find F1 and F2. Number 2, the moment of each of F1 and F2 about the origin point. And then deduce the moment of the result about the origin point. Also, find the length of perpendicular from the origin point to the line of action of resultant. Solution. My dear student, F1 act at AB, then the line of F1 parallel to AB F1 equal K constant AB direction. AB directions equal B minus A. Point B minus point A equals negative 5, 12. What is the norm of AB? Equal square root negative 5 power 2, 25 plus 12 power 2 equals 144 equals square root 169 equals 13. Then the norm of AB or length of AB equals 13. F1 equals 3AB, F1 negative 15 and 36. F2 act at BC by using same method, line of F2 parallel to BC, then F2 equal KBC, K is constant, BC equals point C minus point B, then 3, negative 4. What is the norm of BC or length of BC by using square root 3 power 2 plus negative 4 power 2 equals square root 25 equals 5. Then F2 equals 7 BC by using 7 times 3 equals 21, 7 times negative 4 equals negative 28. The force F2 equals 21 and negative 28. My dear student, we know that if we prove that the action or the line of the action of the force parallel to AB, we must prove that moment about A equal moment about B. If the required, prove that the line of the action of the force bisect AB. Then we must prove moment about A equals negative moment about B. My dear student, this moment very important lesson. Don't forget, the length of perpendicular of the force equals norm of moment of the norm of the force. Norm of the moment, as a first we find the moment and the value of the force by using square root x squared plus y squared to find the value or the magnitude of the length of perpendicular. Length of perpendicular is distance. Don't forget, my dear student, moment has two directions. With anti-clockwise is positive, with clockwise is negative. My dear student, I am very happy to spend such time with you. Thank you. Goodbye.